We're starting the straighten up and fly right maneuver in preparation for parachute deploy. The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration. Skycrane maneuver has started. About 20 meters off the surface.
We're getting signals from McMurrow.
Touchdown confirmed. Perseverance safely on the surface of Mars. Ready to begin seeking the sands of past life.
Looks like we're getting the first image.
This is the most amazing thing. This is what NASA does. This is what we can do as a country.
Hello and welcome to another episode of NASA Science Live. I'm your host, Dr. Mujige Cooper, and we are so excited you could join us today. A new chapter of Mars exploration has officially begun. Yesterday, NASA's Perseverance rover successfully landed on Mars. Over the past 7 months, Perseverance has been en route to the Red Planet, and now it is preparing to explore Jezero Crater, a 28-mile crater once home to a river delta, in search of microbial life that could help us determine if there was ever life on Mars. And if you think that's cool, just wait, there's more. In fact, we've already received some incredible images from Perseverance. In this photo that you see here, that's the view looking down from the Skycrane, lowering the rover onto the surface of Mars. In this next photo, you can see Perseverance's front right wheel on the Mars surface. The scientists are filled with such excitement as they discuss the rocks right nearby the wheels. In the next picture, you can see there's an image captured from orbit around Mars from the Perseverance's parachute as it is deployed and as it descends onto the Red Planet. That is pretty cool. This is personally very exciting for me because when I was in 5th grade, what inspired me to work for NASA is the search for answering whether or not we're alone in the universe. And it's been truly an honor to be part of a team that's venturing to answer these questions. I'm joined today by Gregorio Villar, Entry, Descent, and Landing Operations Lead at NASA JPL, and Dr. Kelsey Moore, Perseverance Science Team Member, NASA JPL ABC Lab. Congrats, you two, on an exciting and successful landing yesterday. Yeah, I'm sure you're excited. So this question is for both of you, but let's start with Kelsey. How does it feel to land a rover on a planet millions of miles away?
This is incredible. I have watched past rovers and experiences kind of from the sidelines. This is my first time being a part of the mission and the team, and it's a new level of excitement, and I cannot believe that we're at this moment now.
Awesome. Gregorio, how do you feel? You're a veteran. You've done this before. What's going through your mind?
Moo, I've done this once, but we had never had images like the one you just saw. How cool is that? I've been so used to just watching animations, and just seeing that picture is just so surreal. And it just really shows all the hard work that we all put into this mission can be a success if we just work together.
If we just persevere. So, Gregorio, can you tell us, what is the rover doing right now?
Yes, I can do that. So when you go through a long road trip, right, you're kind of cramped up in a car, and our rover has been cramped up in its spacecraft for months. And so the first thing we want to do is really kind of like stretch our limbs, make sure our joints are okay. And that's what the team is doing. We're doing little checkouts of all of our mechanisms. We're turning on our instruments, making sure they're all good to go. And then eventually in a few days, we're going to do something that's called a flight software transition. So there's an operating system that we use on board, and we use that throughout the cruise phase of the mission. But now that we're on the surface, we're going to need a new set of capabilities so that we can operate on the surface of Mars and let the scientists do the things that they need to do in the future.
Yeah, I just listened to the press conference. They said it would take about 4 days to do the software transfer, so nice and steady, right?
Exactly. With something like this on Mars, you don't want to rush through it, so you do little by little, just not all at once.
Awesome. That's amazing. So Kelsey, from your perspective as a scientist, please tell us what's next.
Yeah, definitely. So once the rover is kind of fully awake, as Gregorio described, we get to dive into the science. So I am a field geoscientist. So on Earth, when I want to learn about the ancient Earth past, I go into the field and I analyze big rock outcrops, and then I collect samples and bring them back into the lab so that I can analyze them in more detail. So Perseverance is kind of our little robotic field geologist on the surface of Mars. So Perseverance will be roving around and analyzing the rocks, assessing the outcrops, getting context for us. And very excitingly, the rover will be picking up samples, collecting samples that will eventually be returned, hopefully on the Mars sample return mission, so that we can then analyze those Martian samples back on Earth.
That is incredible. We know many of you at home have so many questions about NASA Perseverance landing on Mars and the exciting things that it will do on the Red Planet. So join the conversation and ask your questions by writing in the comment box wherever you're watching this, or by using the hashtag #CountdownToMars on social media. But first, let's start things off with a question millions of people around the world are asking. Is Mars habitable?
Is Mars habitable? Well, maybe. The question is it habitable and for whom? Mars is hundreds of degrees colder than Earth. It has 100 times less atmosphere, and that atmosphere has hardly any oxygen. But there may be other forms of life that could have evolved that aren't very much like us, but are very much like the early forms of life that evolved on Earth. Mars has evidence of being warmer in the past and of having stable liquid surface water for potentially hundreds of thousands of years. So it's possible that in Mars's past, there was a time where life could have evolved in that particular environment. We have been trying to answer that question definitively. Is Mars habitable? And as of yet, the answer is still definitely maybe.
Wow, it's so exciting that Perseverance is now on the surface of Mars to help us answer these questions and to search for signs of ancient life itself. The internet is buzzing with excitement over yesterday's Mars landing, so let's take questions from the public. For everyone that's watching, it's not too late to join the conversation. Submit your questions using hashtag #CountdownToMars or comment in the stream wherever you're watching this. Our first question is from Alex on Twitter. Does Percy have any way to move rocks or sand to see what is underneath? This is a great question for Kelsey.
Yeah, so once the rover starts driving around, we can do sort of two types of science. We can analyze the rocks from far away using SuperCam and collect some data that is a couple of meters away from the rover. And then we can also analyze the rocks up close with some of the other instruments like Pixel and Sherlock. And what we'll do is get right up next to the rocks, place those instruments so that they're close to the surface, and then be able to analyze the rocks below. And then we can do some abrading to get rid of the superficial area, and then we get a good signal in the rocks below that are underneath what we call the weathered surface.
Yeah, and
Kelsey,
another
what about that
part.
laser?
Oh, yeah. Go ahead, Gregorio.
Go ahead, Gregorio.
No, I'm asking Kelsey, what about the laser?
Yeah, so we'll be able to use different kinds of lasers and x-rays to analyze all of the chemistry, the mineralogy, the organic compounds that are inside of the rocks. So we're really excited to see what kind of data we get.
Yeah, and another cool feature, you also have the gas dust removal tool, the GDRT, which is able to puff a gas of nitrogen on the surface and blow things away. So that's pretty cool. A lot of great suite of instruments there. Mm-hmm. We have another question from Panda Wannabe on Twitter. Panda Wannabe asks, what precautions did you take to make sure no Earth microbes hitched a ride with you on Mars? And will you be stopping by to say hi to Curiosity? This is a great Kelsey question. I would love to answer it too.
I know, you are one of the experts too. Yeah, that is a great question. So one of the big fears at the beginning when you're thinking about bringing samples back is we don't want to get a false positive. So we don't want to analyze rocks that are brought back from Mars and think that we found evidence of life, and really it's evidence of life on Earth that was brought along for the ride. So the sample tubes, which the samples will be collected in on Mars, have gone through extensive cleaning processes to make sure that they are absolutely pristinely clean. No traces of any kind of Earth microbial matter on them. And so we've done our due diligence, all of the engineers and scientists working on this to make sure that those sample holders are as clean as they possibly can be.
Awesome. Yeah, and I actually have a little 3D printed tube here. So we actually baked out these tube assemblies at 150 degrees Celsius for over 26 hours. So they are ridiculously clean. A lot of effort went into that. A huge team made sure that that was not an issue, the whole false positive. So yeah, we are excited for the science coming from these pristine tubes. The next question we have is from Mike on Twitter. To what depth do you drill, and how long is the core sample that you collect to analyze? Also a great Kelsey question.
Gregorio, feel free to put input as well.
Go for it.
Our samples that we'll be getting back are going to be about the size of a piece of chalk. So here's a video for us. So very small little pieces of drill core. And we're working on ways to make sure that we kind of get the context around those drill cores right before we collect them so that we know what the rocks look like before they're taken and then placed into the tubes and brought back.
That's awesome. And in order to get to this location, just to bring Gregorio in, I mean, to land in Jezero Crater, we needed TRN, we needed the EDL gurus here. Can you talk about that quickly?
Absolutely. So TRN is the Terrain Relative Navigation System that is new, that we did not have on Curiosity, and it really enabled scientists to go to Jezero Crater. There is a hazard map that we have where shows where we landed. You probably saw it in yesterday's press conference, but you can see there are a lot of hazards in Jezero Crater, and they were marked as red. And we were able to sneak right in there into that green little dot that was a safe parking lot area, which is really, really cool. And the way we were able to do that was that during the descent phase, we have a camera on board, and it's taking images and correlating that with a map that's on board and being able to better understand where we are relative to the ground. And then when we know that knowledge, we know all of the safe spots that we would want or that we could go to. So when we're on this jetpack, we tell the jetpack to fly to the optimal safe point on the map. And then, here's the picture where we are able to do that, luckily in a nice, safe area on Jezero Crater.
That's amazing. So speaking of these amazing samples, the next question, a lot of people are asking, how will the samples get back to Earth? Who wants to take that question?
I could give it a shot. So Perseverance is actually the first leg of what's called the Mars Sample Return Campaign. It's going to be a joint effort amongst 3 missions. So Perseverance is the first of that. Perseverance is going to start collecting samples along the way over its mission. And now we're also working on a new mission called the Sample Retrieval Lander. So we're going to send a smaller rover to Mars accompanied with a little rocket. As you can see there, we're going to put the rocket on, we're going to put samples onto the rocket to launch it into Mars's orbit. And then we'll send another orbiter to pick up those set of samples and then fly it back to Earth and bring it back to Earth for the scientists here to be able to analyze them.
Yeah, that is an incredible feat of engineering and an international collaboration too. I mean, it's not only NASA mission, but it's going to involve ESA as well. So that's pretty spectacular. Kelsey, do you want to have some inputs about getting the samples back to Earth? I mean, as the scientist.
Yeah, absolutely. We're really excited about that component of the mission. So the rover, as I said, has some really great instruments that can analyze the rocks on the surface of Mars as it drives along. But there's a limit to our capabilities of the kinds of data that we can collect on the surface. We have a lot of really incredible instruments in our labs that are just enormous instruments, and we don't have the technology to send those to Mars. So getting the samples back will allow us to really dig into the science a little bit more and be better able to characterize the samples. And what I'm most excited about, hopefully search for signs of past life.
That's awesome. All right. Our next question is from Marina on Facebook, and this is really for Gregorio. Where is the jetpack and parachute now?
Ooh, yes. So the jetpack, or what we call the descent stage, after it does its job and lowers the rover on the ground, it flies away from the rover and just crash lands away from us, somewhere over 400 meters away. The parachute also does the same thing. So the parachute is controlling the aeroshell or the back shell, and it's floating away. And we're going to try to do what we did on Curiosity, where we had images from some of our assets, and hopefully we'll get some pictures sometime in the future to see where these things are located on Mars.
Fantastic. Awesome. The next question is from Yvonne on Twitter, and it's for Kelsey. Does Perseverance have a way to measure the density of mass of rocks? Those porous looking rocks make me want to know if they are light like pumice.
That's a great question. Yeah. And something that the science team has been talking a lot about, trying to figure out exactly what those rocks are and what they mean. So we can do a few things to try to characterize the mineralogy of the rocks, figure out if it's a basalt that maybe has basaltic type minerals, or if it's a sedimentary rock that has different kinds of clays. So we will be integrating a lot of the different data sets that the rover is collecting and try to answer that question of how dense is it, what kind of minerals are there, what kinds of elements are there, so we can get a good approximation of what the materials are that we're looking at.
Yeah, and there's also one of the many assessment stations in the adaptive caching assembly part of the rover is a volume assessment station, so that we can actually measure not the density of the rock or the mass, but at least get a rough idea of how much sample we collected. So yeah, a lot of great things to look forward to. The next question is from Tim Probst on YouTube. He asks, Tim asks, what procedures will you take if we find signs of life on Mars? Kelsey, this is for you.
Great, definitely. Well, so there are kind of two ways that you could go with this. I'm going to take the signs of past life on Mars approach. I'm not sure exactly if that's what they mean, but what I'm most excited about is seeing if life ever did exist on Mars in its ancient past. And so if we do find evidence that there was past life on Mars a few billion years ago in a similar age to the most ancient life that we have evidence of on Earth, I think it's going to be really exciting to analyze that and reframe how we think about what types of environments are habitable, how life emerged in the past on different planets. So it will open up a lot of science questions that we can then ask. And I'm really excited for the next couple of decades and what that means for scientists as we try to answer that question.
Yeah, and Gregorio, just as a human, I mean, how would you react if you heard that they found signs of ancient life on Mars?
I would be really relieved. One of my favorite movies growing up is Contact, and it kind of instilled upon this idea of like wanting to be life out there. And in the movie, the main character was asked, do you believe in life outside of Earth? And her response was, well, if there wasn't, that would be an awful waste of space. And so I'm always hopeful to find signs of life anywhere outside of Earth.
Yes. Big brownie points, also my favorite movie.
Yeah.
Awesome. Our next question is from Ryan on Facebook. Will it be possible for us to verify the prior existence of life on Mars without the return of samples that we take with the mission? So Kelsey, could we verify the existence of life on Mars without returning the samples?
That is a question that I ask myself every day. It is an excellent question. So there are kind of a range of different types of what we call biosignatures. So those are evidence of past life. That can be actual fossils, little individual fossils of bacterial cells and things like that we do find on ancient Earth rocks. It can be stromatolites, so microbial structures, like when you see a kind of scuzzy mat on the surface of a rock in a pond, those microbial mats can get preserved. Organic compounds, carbon-based compounds. So all of those biosignatures have different chemical compositions, different elemental compositions, different textures associated with them. Some of them are really easy to identify, and some of them are not quite as easy to identify. So it'll take a lot of work for us to really analyze them using the instruments on board and see if we can convince ourselves, depending on how obvious those potential biosignatures are. So maybe we'll see.
That's very fascinating. I love how it leverages all of your experience in the field, and how you're applying it to Mars. That's pretty crazy. Pretty great.
It's exciting.
Yeah. The next question from Luke on Twitter is for Gregorio. How long before Perseverance gets driving around?
Ooh, that's really highly dependent on how things go. There is a nominal plan for us to start driving, but I would say it's on the order of a few weeks or so. But again, we're doing all of our checkouts, and we're gonna have to go through a software transition, and then after that, we're gonna go start looking for a helicopter pad for us to be able to use our helicopter ingenuity.
That's awesome. Yeah, so that's incredible. The next question is from Patrick Fleming on YouTube. He is a big Dr. Kelsey fan. His question is regarding studying astrobiology. What does the career consist of? What subjects do I need to focus on to study this career? And thanks, congratulations, NASA.
This is one of my favorite questions. The answer is there is not one single path. There are so many different paths that you could take to become an astrobiologist and study life in the universe. On our science team, we have this incredible group of people who have backgrounds in chemistry and physics and biology and geology. And all of those people come together, and we're living in this really amazing moment in science history where science is so interdisciplinary and collaborative that we all can work together to put all of those different types of science together. So I would say my advice is study what you're passionate about, what you get excited about, whether that be any type of science, any type of math, engineering, and just push it forward. Follow your dreams, and you will be able to get to a position where you can integrate that in some way into astrobiology.
That's amazing. And since we're on this topic, Gregorio, I know you have a great story about how you got to where you are today.
Oh, right. So when I was an undergrad, my professor was asking if I wanted to help out one of his old postdocs who was working at JPL. So I said yes, and I had this fortunate opportunity to work in the Palomar Observatory. And I remember the first time I was able to be inside that ginormous telescope, and I noticed, like, this is what I want to do one day. And I think that's a really important message for everyone out there. It's whether you want to get into a specific field or you don't know what you want to do, I think it's important to find something that you love to do. Because I'm sure for Moo and Kelsey and myself, we probably never really feel like we're going into work just because we love it so much. And so that's what I did. When I started college, I was actually doing accounting pre-law, and I wasn't really enjoying it. So I made the switch over to physics, and physics led me to astrophysics, which led me to JPL, which led me to doing some engineering, and now has let me be part of this amazing team that landed Perseverance on Mars. So everyone should be able to find something that they love to do.
Yes, so you too can be a Dr. Kelsey Moore one day, or a Gregorio Millar. Work hard and follow your passion.
Or Dr. Mujige Cooper.
Sure. Or that too. All right, the next question is from Harmony on Twitter. How much of the planet will Perseverance be able to explore? Kelsey, this is a great question for you.
Definitely, yeah. So the rover is going to start out looking at Jezero Crater, the landing site of the rover, and analyzing. There are some really incredible rock deposits here. As you said at the beginning, this is a river delta. So we're really excited to find out what kind of changes in the rocks we can see as we drive up around the delta, and then eventually go outside of the crater and potentially extend the mission beyond that. So for right now, we're going to kind of stay within the bounds of the crater and look at the delta, and then potentially expand farther out.
Awesome. And to follow up with that, Dr. Moore, Eric on Facebook wants to know approximately how long until the first sample results will be tabulated and analyzed?
Oh, that's a really good question. I don't have an answer to that. It's going to depend on what rocks we see as we drive around. So one of the best parts about being on this science team and having these really great discussions with all these different scientists and engineers is that we get to talk about it as we go, as we see rocks that look like cool rocks to collect. We get to have conversations and learn about the rocks and decide which ones we want to collect. So we'll have to see what the rocks look like.
Awesome. So Amiel on Facebook wants to know from Gregorio, is there a delay in controlling the rover on Mars?
Yes. So I like to bring up remote control cars, like here on Earth. And so if you ever push forward on a remote control car, it moves almost immediately. But because Mars and Earth are so far apart, depending where they are in their orbits, it will take anywhere between 5 and 20 minutes for a signal to get relayed between each other. And so when we did entry, descent, and landing, it was an automated process because at that time, a signal would have taken 11 minutes or so to be received between the two planets. So we have to account for that in surface operations as well. And every morning, we'll send out a set of instructions to the rover, to Perseverance, and Perseverance will execute those set of instructions. And before it finishes for the day, it will radio back what the information they got, and we'll use that to plan the next day while Perseverance is asleep.
That's awesome. We have time for one last question. So let's ask from Nathan on YouTube. What data will we be listening to for sounds on Mars? And what data will we gather from that planet? I'm guessing Nathan wants to understand the microphone data and what we're listening for. So let's hear both of your perspective. Now, let's start with Dr. Kelsey.
I was going to pass it over to Gregorio actually first.
Oh, yeah, let's hear it.
Okay.
What are we listening
So, right. Well, so maybe I'll talk about the camera, the microphone that we have on the EVL system, and Kelsey can talk about the one that's on the rover. But as part of our EVL system, we equipped it with a microphone. And the idea was that it would be recording sounds during entry, descent, and landing. And so hopefully we'll be able to hear things like the engines firing or the parachute deploying. And so we really know, I mean, for certain, since we've never done this before, what we'll hear. But that's at least what we have the microphone for on the entry, descent, and landing system.
All right. Sorry, Dr. Kelsey, we don't have time for your amazing answer. I know it's going to be great. Thank you so much. Those are great questions. Thank you to Gregorio and Kelsey for joining us.
Thank you so
Thank
much
you
for having
us.
And thank you at home for joining. If you'd like to follow Perseverance and its journey to the Red Planet, please make sure to follow at NASA Persevere on Facebook and Twitter for the latest updates. And don't forget to bookmark mars.nasa.gov so you can see all of the photos and the sounds collected by the rover once operations begin. You can also follow every step of the rover's journey with the Explore with the Rover Toolkit. If you're an educator, it's not too late to join and bring your students along. Visit go.nasa.gov/Mars 2020 Toolkit to access the Mission to Mars Student Challenge. Until next time, see you soon.